Welcome anybody. So here's the video that I just got done making a week or so ago. And here's what it looks like when it runs. And that's great, except after I was watching the video I made, I kind of felt like I didn't really finish. Namely because I said I was going to show a program of how to read and write to a pipe. But literally, when it came to reading and writing the pipe, I did a function call that behind the scenes did the work, and it didn't really show how to do it. It just shows the setup of the program, and then a function call to do the work, and then thank you, wham, bam, thank you, ma'am, we're done. So I felt like I needed to do a part 2 video. What I'm going to do in this video is I'm going to attempt to rewrite this line 24 here, the write to file. I'm going to write it to show what the code it takes to write to file, and I'm going to rewrite this function that reads from the pipe, so you can see what it takes to actually read from a pipe. And I wanted to clarify a few confusing things in the video that I had said that didn't really sound quite right after I was listening to it. For example, this void here. The void object is in the data block. So when I use the word initialization, there's not just one level of initialization. Sometimes there's 2 levels of initialization. The first initialization is to create the object. Well, since this is in the data block, it's literally kind of like a static object that's created at compile time. So it exists in program space without being initialized. It has all the default values copied into it, and it's not an object that needs initialized. It doesn't need to be killed and returned to a memory manager and all that jazz. It just always exists. But it is a void, and a void, what it is management of heap memory, or a memory block. And it's that memory block that needs to be initialized. So that's kind of the situation. There's not one level of initialization, there's 2. The next thing that I wanted to look at here was these write lines. So here it says my void dot write line. Looks okay, right? Well, the compiler accepts that, but the IntelliSense doesn't like that. For example, let's redo this line. Now when I type in the first dot, it gives me these 4 options here. And if I go to type in write to file, it doesn't like that. It's not one of the options IntelliSense offers. And that's why when I try to type in a left parenthesis, it gives me a 9, which is a glitch. I mean, that's not right, but it's kind of why in the video this look like this. The IntelliSense doesn't like it, even though the compiler will accept it. What the IntelliSense wants you to do is use one of these 4 words, such as code. Now that accesses the code or the functions for the object. And now you can find write to file. That's what IntelliSense wants. There's also another variation of what IntelliSense will allow you to do, is after you type in the first dot, you can actually hit a second dot. And what that gives you is it gives you everything that the object has. All the functions and variables mixed in. At that point, you can type in write to file. So IntelliSense likes that, and that. Likes the double dot, likes the dot code dot, but it doesn't like the just plain old dot write to file, write line, even though the compiler figures it out and will accept it anyway. And there's that situation. Not so great. But that's it. That's the truth. The next thing that I didn't quite like was, I think it was, yeah, this write to file. The second parameter here is an optional parameter called offset. I believe in the video I said that that would be the offset in the void of where you want to start printing from. Well, that's not correct. The whole entire void will print. You have no options of which offset to start at. What that is it's the offset in the destination file where you want to start writing to. And the reason for that is let's say you want to write multiple voids to a file. With that offset variable, you can write them back to back. That's what that offset is. Last thing I didn't quite like was sometimes my function names aren't really great. And this .new here, it's overloaded. It gets you, one of the options is for an HReadPipe, which is what we use. And it really, yeah, it does create a new void. Yeah, it does read the pipe and fill up the void with the pipe. But it's not really completely obvious that that's what .new would do. Don't really like that too much. But it's not bad. It's just the way it is. So, without too much more rambling, I want to attempt to write the write file function. So, I'm going to go function write to file, and I'm going to accept DQ, which is a handle. And you know what? I'm going to go ahead and do this offset again, even though I won't use it, just so we can see what it looks like inside of the function. I'll make it optional as well. Maybe I'll call it dest file offset. Maybe that makes it a little more clear of what it is. There's something I need to edit out of the video. I can't seem to pause my video. To get started, like I said earlier, real coding doesn't start on line 1. It starts somewhere in the middle and then you fill in what's missing. I know that when I write the file, I have to do a Windows API call. I'm going to start with that, see what I'm missing, see what's blank, and then kind of fill in the gaps. So let's look in our Win64 namespace, and let's look under the code. I'm looking for, I believe it's called write file. Now these parameters I struggle with, and I don't like them, to tell you the truth. And I'd like to change the world of how this works. But I can only do so much so fast, and interoperability is something I've not done much with. This compiler doesn't have any interoperability with other languages at this point. But it does have to have interoperability with the operating system, and this is where the rubber meets the road when I'm trying to do an API call. Now Windows has changed things throughout the years, and what's documented now for these functions isn't what you're seeing on my screen. This is an old Visual Basic, I think it's Win32 API.txt. It got upgraded to Win64. So this is old, and I probably don't like the new much better, to tell you the truth. But what it comes down to usually is, the compiler has to know, do I send in the value or do I send in the address or where the value is located in memory? That's the two questions you got to ask. So The first parameter, it literally says byval in front of it, which means, yeah, you're going to want the value sent in. Handle. The second parameter, any. I've struggled with any before. Typically what any seems to mean from my recollection is that you want the address of where the value is located, the address of the buffer. What we need is something we don't have. Yeah, the void from up top. This my void is where the data is located in the buffer, and when I did the write to file on this line, it was encapsulated within the my void object. Now that I have a function here, write to file, I need some void passed into the function. Now, ironically, since I did that as the first parameter, that's exactly what's going on up here. There's a hidden first parameter, which is the address of where the my void object is located. It's one of those object-oriented programming secrets. So this function here that we're writing has 3 parameters, literally sends the same as the other function. But we have 2. Yeah, that's all I got to say about that. So let's see. We need an address to the buffer. Let's try, see what some void has. That's the address of some void. That's actually the address of the stack of where it's at. Let's go look at the variables of some void and see what we got here. Reference. Let's look at reference. I think address pointed at. So the reference apparently is a pointer, and we want the address pointed at by the reference variable, and that is our address of the buffer. See what else we got. Number of bytes to write. Okay, for right now, I'm going to put EAX in there. Notice how it says long, byval long. So it wants a value. A long is 4 bytes. So I'm going to send EAX, which is a 4-byte register. And we'll have to work on that a little later. See what the next one is. Long, number of bytes written. Okay. Number of bytes written. I'm going to go ahead and put a variable in there that doesn't exist yet. The next one is the overlapped structure. It's a window structure. And we're going to have another variable we haven't created yet. So we have some work to do here. Let's define a couple variables. I'm going to make a variable called number of bytes written. Notice it's a DQ, whereas it wanted a long. I do that on purpose. What it's going to send in number of bytes written. A long by default passes by reference. So it doesn't have the by ref on there, but by default it passes by reference. So what gets sent in is the address of a variable that's 4 bytes long, and the Windows will be able to write into that address the number of bytes it wrote out to file. Now, if the variable is actually 8 bytes long, it's longer than necessary, it's extra 4 bytes that you don't even need. So it's okay. it'll be okay to do that. We can declare this a DQ even though it's writing, because of that little end in principle. It uses the first 4 bytes, not the last 4 bytes. So that'll be okay. Let's make another variable here. I'm going to look for the overlap structure. So I go through the Windows Win64 namespace. I know it's a UDT, and I believe it's called overlapped. Okay. And I'm going to name it OLAP. While we're here, we're going to deal with the destination file offset because that's part of the overlap structure. Let's go move OLAP dot offset. And we're going to put in there EAX. So since I declared this variable up top in DQ, but the structure only wants a 4 bytes, I have to do a little movement here. Move into RAX dest file offset. And then I only use the 32-bit portion of the register, and that moves it into the structure. Okay, sorry if this is confusing. It's confusing for me too. The next thing is let's deal with this EAX here that we skipped over. Number of bytes to write, a bival long. Okay, so it's sending in a value, 4 bytes. All right, I'm going to move into RAX and do my same little trick here. The question is how big is the void? And I have some variables in the void, quantity and quantity used. Oops, 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 blinking all over the place. So when I put the quantity used, that's an 8-byte value. I put it in RAX, and then I only use the 32-bit portion of RAX for the parameter. That should work. Now the return of the function is non-zero on success in the RAX register. Let's look at the RAX register. Let's do a compare. Jump if it's not equal to 0, which means success, but if it doesn't do the jump, it means failure. Let's invoke console.code.writeLine error writing to the pipe. Return. I think that's it. Let's do a compile here. Sorry, you cannot store data on the stack larger than my message box times out. I did recently put a timeout on my message boxes for the log, and it's still there, thank goodness. At least it highlights the line and it keeps blinking away from the log tab. Cannot store data on the stack larger than 8 bytes. Try using the data keyword to store it in the data section. Okay. Again, exactly what it says. It does not want to put any structures on the stack. You got to have it be static in the data section. Let's try that. Compile was successful. Fantastic. Oh. I can't run this yet because I'm not done. This write to file up here, that's still the old call. We're going to now make a new call to our new function we wrote. And the void is my void, and the handle is HWritePipe, and the offset is 0. It is optional, so let's just leave it off this time. There, let's compile and run that now. Compile was successful. It worked. Fantastic. Our next function won't be as simple, the reading from the pipe. Let's see, let's call it read from pipe. Again, you're going to need to probably send in some void into the function. Probably need to send in a handle. And we won't have an offset. Likewise up here, but let me do this before I forget. Let's call our new function, read from pipe. And let's send in the mydest dot variables dot void. And next parameter is the HReadPipe. Okay, so I'm not gonna go from top down of what the finished product will be. I'm going to do it like the natural way a programmer works, and that's kind of from the bottom up or the middle out. I'm going to start with the API function that I'm going to try to use, and then I'll fill in the gaps. So the API function I'm going to try to use today is in Win64, and it's called peak named pipe. Now I would have guessed there's probably more than one ways to read from a pipe. This may not be the easiest way to read from the pipe. I don't know. This is what I'm going to be doing today. Now the handle is the handle, and you notice that's a long pointer, so that's an 8-byter. By value, that's fine. Buffer. Any buffer. Okay, that's an address of a buffer. What we're going to want is some void dot variables dot reference address pointed at. Sounds good. Buffer size. How big is the buffer? It's going to be a 4-byter. Well, that's kind of a problem. All these are going to be a problem. We don't have them. I'm going to do that one EAX, 4-byte variable. Bytes read. Okay, another 4-byter, address of a variable. I'll just call it bytes read. Another 4-byter. Bytes available. Call that one bytes available. Available. Bytes left this message. Bytes left this message. Alright, sounds confusing. I'm confused. There's our variables we don't have. Plus the AX. Let's declare them. This time, instead of making things more difficult, making them all DQs. I'm going to make them all DDs, make them match the function call. I like a space there. Now, one of the problems we have at EAX, let's go back to that one. Buffer size. We don't know what the buffer size is. We're just reading from a pipe. That's a problem. I do know that if we move into RX, sum void dot variables dot quantity used is how big the void is using, how much of the void is being used by the data, which is nothing at this point. It's not initialized. But that's the variable we would need. Like that. So I did some reading on the Microsoft documentation, and it turns out before you get to your real call of peak name pipe, you can do a trial run call of peak name pipe. And if you were to not give it the buffer address, you give it 0. And if you were to not give it, say the buffer that's 0 is also 0 big, basically saying, I want to peak the pipe, but I don't have a buffer. Then it'll actually fill in bytes available for you. Then you'll have it. So after that function runs, let's compare bytes available with 0. Jump if it's greater than. It's not greater than 0, which means it is 0. And let's return. Although I want all my functions to return, error or not error, the flags register being 0 or non-zero. And right now, after that compare, 0 minus 0 would be 0, and it'd be kind of indicating error condition. Where if the pipe is empty, I don't really want it to be an error condition. I want it to be just, hey, there's nothing there. Not an error, just nothing there. So what I want to do is kind of clear out the RX register if there's anything in there and add 0 to RX. What that'll do is it'll make the flags register let's add 1 to it. What that'll do is that'll make it'll be a non-zero, and it won't trigger an error, in other words. Okay, so now we should have bytes available. I do want to kind of make this read a do loop, and I won't be testing that the do loop actually works for larger buffers. There won't be a lot of testing here. This is going to be a very simple example. So let's see what we got here. Now the bytes left this message, I really not going to use that, even though it's there. Bytes available, bytes read, EAX. All right, let's give that a shot. After it runs that function, I do want to compare the bytes available with the number of bytes, oh, not number of, with the bytes read. Which means if the bytes available equals number of bytes read, then the entire remainder of the pipe was read. JG. Jump greater than. So if the bytes available is greater than the bytes read, which means not all of it was read in, the jump will happen. And the jump will go up to... I don't like that. It's going to go up to here. Yeah, you know what? I need a line of code here. You know what? I actually forgot something. Forgot something important called initialize the void buffer. Call it the sum void buffer. I never initialized the buffer. Let's do that. We'll come back to it. So let's do invoke sum void dot code dot new, and there's our two new functions. Size DQ. My bytes available is a DD. It's not going to like that. Send in RX. Description. Okay, this description we're not going to use here today. This is just for memory management. I'll just type something in there. I need to pull off the variable called bytes available. And initialize the void, initialize the buffer. Okay. Now I don't need that no-op. Don't need this line. So this jump greater than, the logic will be is it's going to go up to the first line up that's equal on indentation, and I'll go down the line after that, which is right there where we want it to go. Thus the creating our do loop. The do loop will finally exit when the bytes available equals the bytes read. Now, this isn't really a very good production type of a read, because you need some sort of a kick out if it's an infinite loop protection. So I'm not going to do that today. Just trying to slap this together for a video. There is one thing I'm jumping around. This is so bad. I didn't do the bottom here. So one thing at the bottom is that this sum void dot variables dot quantity used. So the quantity is filled in with how big the buffer is, but the quantity used represents how much the buffer is being used. It's a very important property to fill in. And it's an 8-byter, so we need RX. And we're going to move into EAX number of bytes read. Sorry, not number of bytes read. And yeah, I could see where there needs to be a lot of testing on this little piece of code here as far as how this could fail. I'm not gonna, for a simple example, let's give it a shot. See what we got. Let's kind of document this separately. So this would be. I'm gonna document it. Let's give that a create. Compiled good. Did not run run so well. Well, this is what I'd call the good, the bad, and the ugly of programming. You're not going to type these things in perfect the first time, or second, or third, or fourth, or fifth, even if you've done it right a few times. So there's a mistake in here somewhere. I know this code mostly should work because I've written it before, but I haven't quite typed it in right. So now I could go off video and figure out the problem and fix it, but then we kind of lose the process of how do you find mistakes like this. And I'm going to go ahead and go through the ugly part of how I do this. The reason I have to do it the hard way is because this compiler doesn't have a built-in debugger. I have to use a third-party debugger. And one of the things I do, one of the tricks I do is I do a little trick like this, because I need to be able to stop the debugger at the point in time I want to watch it run. So I do this. Move into RX, some hex number. DAD, D-A-D-D. Now what I'm going to do is I'm going to compile it. And now I'm going to go to the debugger. Yeah, I just opened up the exe. I do have to press run to get it to the point in time where the entry point of my program. That's just how this debugger works. And to find that DAD, I do a search for current module, a constant. I retype in DAD. It's going to search for the DAD. It found it. And I already have a stopper put on that line. Sometimes it remembers my stoppers. You got me. I guess I debugged this off video. So I know where the problem is. I'm going to pretend like I don't know what the problem is, and we're going to continue. So let's press full speed on the program, and we hit our stopper. Now we're going to watch our function. And I used to kind of stress about each one of these lines, but I kind of just focus on the function calls. So I know what all this is going to be. It's going to be loading up in preparation for the function call. And I'm going to go ahead and run this one. The first thing I'm looking for is REX return 1. Non-zero on success. That's good. So according to the Windows API, it's like that was a good function call. Boom, we jumped over error. And then this line right here, I remember from our code, literally writes a stack value into AX. Well, that is how big, I think it's called bytes available. Total bytes that's available in our pipe. Now this jump here is going to be that text that I typed in void pipe data. The next call is going to be for our void. Now I know that this RCX register contains the first parameter, first hidden parameter, by the way. We're going to take a look at that. It's actually, see how that says void right there in it? Well, I've got, these are all helpful things that I put into my functions and modules that could be commented out to make them smaller, but when you're in the memory, you can actually, it actually kind of puts its name at the top of the paper, so to speak. So I kind of know that that's the top of a void object. And within the void object is a couple string objects. And they've got their name at the top of their section too. They kind of stack on one another. I'm going to go ahead and run this, and you're going to see the data change a little bit when I run this. See this address right here? It filled in. It's actually 8 bytes. I can right click on that. And this debugger is kind of nice. nice. And I can follow that keyword, dump 2. That's actually my buffer. Now, I'm going to go down here, and I'm going to run my next peek. And I ran it, and there's nothing in the buffer. That's not good. Now we're going to go ahead and compare 0, number of bytes read 0, versus number of bytes expected, which is 61, and jump greater than. Yep, we're back to the top for a do loop. Remember I said there's no kick out on the do loop so it could be an infinite running loop, and that's essentially what we're going to have here. Is that we run this thing and it doesn't read into our buffer, and it keeps cycling through the do loop. It's an infinite do loop, which is why it just stood there and stared at us. So what happened? Where's the mistake? First thing I'm thinking is we're going to go back to the code and take a look. Although we could probably figure it out here. The parameters, so let's go right here to the, look at the parameters. So the first parameter, if I forget what the first parameter is, hold on a second, let's take a quick look. Let's look at the parameters real quick. Actually, you know what? I think we can do this. Forget what 40 is. There's an address. That's probably the address of the buffer. 328.920. Yeah, okay, we got that right. The next one is R8. Size of the buffer. I remember that. The size was right after the address of the buffer. So it's 0. I was basically saying, here's the address of the buffer, but the buffer is 0 bytes wide, which is why peek name pipe didn't put anything in the buffer, because there's no room in the buffer. Yeah, so it's all a mess. So why is that parameter R8 0? So we need to look into. That's our problem, because it needs to be, I believe, 61 or even larger. When I say larger, is that these buffers have a minimum size for memory block. I think it's like 4,000. So even though we only need a little bit, it's going to have a minimum size. Right here, handle. I should remember that. That's what I thought. Handle is the first one. Address the void. EAX is our size of the void. And you look right here, quantity used. That's not what we wanted. We wanted the quantity, which is the full size of the buffer. Not how much the buffer we're using, but how much is available. Big difference. That's our mistake. Let's create it. Let's run it. And we get results. Fantastic. Let's take that out of there. And that is, I guess, the full version 2 video of how to read and write to and from a pipe. Thanks for watching.